So today we are going to do this question. The question is determine the dimension of power. So you have to find the dimension of power. So first, writing it, we have to write power. We know the equation for power, which is represented by P, is V into I, where V is a voltage and I is a current. Now we can write voltage. That is, we know that equation for voltage is equal to W by Q. So we know that the equation for voltage in terms of energy and charge, voltage is equal to energy by charge. So we are substituting this over here in power equation. So instead of voltage V, we are writing W by Q into I. Now we know that Q, which is charge in terms of current and time, that is Q is equal to I into T. So we are substituting for Q here. So it is energy or work by charge. Instead of charge, we are writing current I into time T, and here also can write capital I and into this I. So here you can see both the currents get cancelled out. Okay, so now the equation becomes work or energy by time T. Now we know the equation for work. W is equal to force into displacement. Okay, so we are substituting instead of work over here, that is force into displacement by T. Now we know the equation for force, which is equal to mass into acceleration. So instead of force, we are writing mass M into acceleration A into displacement D by T. Now the equation is mass into acceleration into displacement by time. Now in this form, now we have got the equation of power in this form. So after getting the equation of power in this form, we will convert it into dimension. So now we have to write the dimension of this equation. So we know that mass, dimension for mass M, it is capital letter M. And for acceleration, you have to know that acceleration is equal to change in velocity by change in time, and its unit is meter per second square. So meter per second square. So and in dimension, so here the unit of acceleration is meter per second square. So instead of meter here, in meter in dimension we will write L. So L by second square, which is time. So it is represented by capital T in dimension. So it is T square. Now we have D by T. T is what? D is displacement. So it is also represents L. Okay, D displacement or distance. So it is represented by the letter L. And again T. T is again time. So it is again T. Okay. So this we can simplify and write. 2L is there, L into L, so M into L square, and T into T square, T square into T becomes TQ. So power is equal to ML square by TQ. This is a dimension for power. So once again, for finding the dimension of power, first we have to write the equation for power. So we know that power is equal to voltage into current. So instead of voltage, I am writing voltage is equal to work or energy by charge. For charge, I am again substituting that charge is equal to I into T. So this I and this I get cancelled. So now the equation becomes work by time. Now we have to substitute for work. That is, work is equal to F into D, that is force into displacement. So now the equation of power becomes, that is P is equal to force into displacement by time. Again we can simplify this equation, that is force is equal to mass into acceleration. So we get the equation for final equation for power as power is equal to mass into acceleration into distance by time. Okay, force is equal to mass into acceleration. So we get this final equation, and from this equation we are finding the dimension. That is how we get the dimension of power. Okay, so we have to know that mass is represented as a capital letter M in dimension, and acceleration, its unit is meter per second. So it is L by T square, and displacement is represented by L, and time T, it is again represented by T. So we will get power is equal to ml square by TQ.